All right, so good evening once again, guys. We had looked at how to plot graph of a linear equation from last class. And today we're going to be continuing. We define a linear equation as a graph with the first degree variable. Now, what do you mean by a first degree variable? It means that if you have the unknowns are the x or y's in the equation raised to the power 1. When you plot those graphs, they will give you a straight line. So the first degree here is referring to the power of the x and y being 1, the power of x and y being 1. So for these equations, you will get a straight line. All right. Now, because of that, we call them linear equations, because those equations give you straight lines. For instance, if you have y equal 5x plus 3, when you plot that, you will get a straight line because the power of y and the power of x here will be to the power 1. All right, so you were given this equation to do for homework from last week, and that I don't know how many of you actually got a chance to do it. Let me see the answer to those who have actually done this graph. I know 1 or 2 persons have done it because they actually sent it to the WhatsApp. Ms. Caveira, you had done this graph, right? Mr. Lamar, did you get a chance to do it?
I did not do the graph, sir.
Oh, Ms. Caveira?
Was that the first one we did in class or the second one?
This was the second one that you were supposed to do.
No, I did the second one.
What you say, you did it?
No, I didn't do the second one. I didn't understand the second one.
Okay. All right, so your range of values would go from -3 to +3. So the x values go from -3 to +3. And if you notice here, the table is such that we only take 3 x values. We take the -3, 0, and +3. Now, it means that we would have skipped out -2, -1, 1, and 2. And can anybody tell me why we can only just use 3 x values instead of all of them? What do we call these kind of equations when they have the power, x and y have the power 1? What do we call them? They are known as, anybody? It is right in the definition here now. They are known as linear equation. And it means that it gives you a straight line. So if you are going to draw a straight line, you really don't need all the points. So you really only need at least 2 points. But to be a little bit more accurate, we can have 3 points. So what we do is to take the x values from the extreme end. So from the negative end, we take -3, and from the positive end, we take +3. And somewhere in the middle, we would take another point. So in this case, we take 0. All right, so we only need to calculate the values for these 3 points. And so as before, we would now have our row for the 5x below the x row. So here we would have 5x. So each of these x values would be multiplied by 5. So when x is -3, 5 times -3 give you -15. When x is 0, 5 times 0 will give you about 0. And when x is +3, 5 times 3 will give you 15. So this would be for the first row below the x row. All right, so the next row, you see that we're just simply adding 3. So right across in that row, we will just add a 3. Now to get our y values, we add the columns beneath the x row and the, well, I should say between the x row and the y row. We just add those values in the columns. So for the first column with the -3, we add -15 and +3. So -15 plus 3. So when you have a negative value and a positive value and you're adding, you find the difference. So take away the smaller one from the larger one, keep the sign of the larger number. So it's, you take away 3 from 15, you get what? 12. And in this case, the larger number has a negative sign. So we are going to have the answer to be -12. So our next value would be when x is 0, we see that we're adding now 0 plus 3, and 0 plus 3 give you a +3, and that will give you the y value. And when x is +3, you see the column below, or the 2 rows below in that column, you would have 15 plus 3. You add those, you get 18. So our y values would be -12, +3, +18. Our x values would be -3, 0, and +3. So to get our coordinates, our points, so we are going to group for this column where you have -3, we take the x value, -3, and pair it with the y value, -12. So our first point will have the coordinates -3 and -12. All right, so these are the points that we're going to be plotting on our graph. The next column would have x equal to 0 and y equal to 3. All right, so these are what we're going to be plotting on the graph, guys. Now for our final column here, we have x equal to 3 and y equal to 18. All right. So we only need to plot these 3 points on the graph, but we're still going to need to have a scale in order to somewhat have a sense of where our measurement will fall. All right, so let us move on to the next slide. All right, so here, if we are going to plot our graph here now, we need first and foremost to draw our x and y axis, but we have to do so in relation to this scale. So for the x axis, we look at our x values. We see that our x values go all the way down to -12. And so that would be the lower end of the y-axis. And the upper end of the y-axis, you're going all the way up to +18. So for the y-axis, you really need to be able to have a scale going from -12 to +18. Now on the x-axis, to the left of the origin, you're going -3, and to the right of the origin, you're going +3. Now it is always wise that you draw your axis based on these values, So you want to bear in mind that you're going 3 places to the left of the y-axis and 3 places to the right of the y-axis. So you want to position your y-axis, which is a vertical axis, in such a way that you can measure 3 units to the left of it and 3 units to the right of it. And here we would put it probably somewhere in the middle there, and then we will go all the way down. And that will give you your y-axis. Now, if we should check now to see whether or not we are able to count 3 units to the left. So from the y-axis, it should be able to go 3 units to the left. So if we start right here and we count 1, 2, sorry, at the y-axis we call that 0. So the next one would go 1, 2, 3. So we are able to go 3 units to the left. And to the right, we should be also able to go 3 units to the right. So we go 1, 2, 3. That means we would have positioned our y-axis in the appropriate place where we can go 3 units to the left and 3 units to the right. Now, the next step now is to put in our x-axis. But we want to position our x-axis so that we can go 18 units above the x-axis, because we're going up to positive 18. So we have to have 18 units above the x-axis for the positive values. And then we need to go down 12 units because we are going down negative 12. So we need to have enough space to go down 12 units below the x-axis. So we might take a little check. Now we notice that these boxes here, the medium-sized boxes, they are centimeter boxes. Now, if we want to go all the way up to 18, and if we take one of these boxes to be, say 5, we could go maybe from here, we could check 5, 10, 15, 20. So that would have given us enough space above. And so we take the same scale going down, 5, 10, 15. We only need to go down negative 12, so we would have enough space. So it means that would give us a good place to put our x-axis. So we could put our x-axis right along here, since we have enough space to go up 18 units, and we also have enough space to go down 12 units below the x-axis, all right? And so once you put in now your axis, your next step now is to write your scale and label your axis. All right. So based on the x-axis, we could, if we are starting out at 0 here, we could count 1 unit, 2 units, 3 units right there, right? So it means then, in this position, we could easily put our units. Now, based on the scale, one of the length of these boxes would be 1 centimeter. All right, now we check to the left of the y-axis and we do the same. So we go 1 unit, 2 units, 3 units. So we have enough space to go over negative 3. All right, so our scale on the x-axis would be 1 centimeter represent 1 unit. So that would be our x-axis. And over here, we have the positive x. Over here, we would have negative x. Then we put in our units. So this would be 1, 2, 3. And to the left of the y-axis, we're going -1, -2, and -3. All right. Now, what we want now is to write our scale. So for the x-axis, we are using 1 centimeter. So our scale going to be 1 centimeter equal 1 unit. All right, 1 centimeter equal 1 unit on the x-axis. And then now for the y-axis now, we notice that we will have to use a different scale. So now, instead of using 1 centimeter to represent 1 unit, as we did on the x, now we're going to use 1 centimeter to represent 5 units. So we're counting 5. Ms. Cabrera, a question?
Yes, sir. Why you only need to move up have 3 units on the x-axis, but you need to have 18 on the y-axis?
18 on the y-axis, because once we did our calculation for the y values, we realized that our y values, the largest one, positive one, goes all the way to 18, and the smallest one goes to -12. So we have to have enough space on our y-axis to accommodate these values. All right, because we are measuring these as y values. Is that clear?
Yes, sir.
All right. So because of that now, we use a different scale because we want to account for up to 18. If we use a smaller scale, it won't be able to hold. So we use 5, 10, 15. And then now here we have 20. Now, once we go above the largest y value, we don't have to go any further in our numbering because 20 is greater than 18, so we don't need to go any further. So up here we have positive y. All right, so now below the y-axis, we're going down to -12, but note the same scale that you use above on the y-axis, the same scale you're using below. I have seen students use a different scale above the axis and a different scale below. It cannot work like that. It's always one scale for one axis. So if you're using 1 centimeters for 5 units, for the entire y-axis, you have to use that same unit. All right, so here would down here would have -5. And next you would have -10. And we only want to go down to -12, so we could just label one more number and stop there. So we want this now would be -15. All right, so down here would be our -y. All right, so here we have drawn our axis. Now we need to write the scale for the y-axis. So we're using now 1 centimeter equal to 5 units. Five units on the y-axis. All right, so we have our scale, we label our axis. So the next step now we need to do is to plot our points. Now, remember now, because it is a straight line graph, we don't have to plot all the values for the x's. So we're only picking out 3 values for the x, -3, +3, and 0. You can actually use two points to plot this graph, but to be a little bit more accurate, we're using 3. So we have -3 with -12. So now on the y-axis, sorry, on the x-axis, we're going -3. So we go over to the -3 on the x, and we come all the way down to -12. Now remember, these we are counting by 5. So what one of these tiny boxes going to be? How much unit is one of the tiny boxes? On the y-axis, we are counting 1 centimeter to be 5. So one of the tiny boxes between the 5, how much would that represent?
Sir, 1.
1 unit. Good. So it means that if we're going down 12, so we are at -3 on the x and we're going down 12, that means we have to go down to 10. And then we count 2 tiny boxes below the 10. So we have 1, 2, so 12 would be right here. All right, so here we would put our coordinates, and that would be -3. So -3 and -12 on the y-axis. All right, so that's 1 point. The next point that we have is 0, x equals 0 and y equals 3. So we go to x equals 0, which would be here, and we're going up now, y equals 3. So we are going up from 0. So I have to count 3 of these tiny boxes. So 1, 2, 3. And so the next point going to be right on the y-axis, and it has to be 3 units above the 0. All right, so this point going to be x equals 0 and y equal +3. All right. Now our next point, which is the last point, would be 3 and 18. So we're going 3 here up to 18. So we're going 2 small boxes below 20, and that should give us 18 right here. And so this point here, we're going to have x equals 3 and y equal to 20. And so the next thing now is to just draw our line and connect these points. So here we would have our line going straight to up to here. And that would give you your graph. So we only use 3 points. So we could use only the 2 endpoints if we wish, and we would still get a straight line. All right, guys. So that's the shorter way to do a straight line graph. Instead of trying to plot all the points, you plot the 2 endpoints and 1 point in between. Any question? All right. Let me see the hands of those who are following so far and are comfortable with what they have just learned. Anybody else?
Sir, can you repeat?
I was just asking about if you are understanding what is happening here. And
Okay. Yes, sir.
all right, so I'm going to clear this and move on to the next slide. All right, so our next slide here. Well, this is another diagram of the same graph that we just draw. All right. Now our next graph that we want to look at will be quadratic graph. And so we are looking at quadratic equations. Now we would have met quadratic expression before, but with quadratic equations, you'll have to have an equal sign. All right. Now once you plot a quadratic equation, you're not going to get a straight line, because in this case you have an x square, and this x square is what going to make you get a curve, right? And so for a quadratic graph, you will get a curve looking like a valley or a curve looking like a mountain. Now the name of the curve, we call it a parabola. Some people say parabola. The English people them say parabola. Parabola. All right, so the parabola can shape like a mountain, or it can shape like a valley. Now, you can use the equation to determine whether or not you're going to get a mountain or a valley. Now, if the value for A, which is the number in front of the x square, if that value is a negative, so if it is, that means A is less than 0. So if it's a negative value, you will get a curve shaping like a mountain. And if it is a positive value, you will get a curve looking like a valley. So when you're plotting a quadratic equation, look at the coefficients of the x square and see whether or not you have a negative value or a positive value, and that will give you an idea how your curve will shape. Right? So if you have a negative value, you know you're going to get a curve looking like a mountain. Or if it's positive, you're going to get one look like a valley. And remember, the name of the curve would be the parabola or parabola for some persons. All right, any question, guys? All right, if there's no question, then I think we can move on. All right, next slide. Now, here we have an example 3 here. So we're to plot the graph of y equal 3x squared plus 10x minus 8, and you're to take x values from -6 to +4. Now, looking at this equation, can anybody tell me what the shape of the curve going to be? Whether or not it's going to be a parabola, or it's going to be a mountain or a valley? Anybody can tell me? What shape the parabola going to have?
Sir, can you repeat, because I'm not hearing well?
So I'm asking, based on this equation, looking at the coefficient of the x squared, the number in front of the x squared, what shape will your parabola have? Will it have a shape like a mountain or like a valley?
Valley, sir.
Okay, and what you use to determine that?
The coefficient is positive.
Right, so here the 3 in front of the x squared is positive, and once it is positive, your curve will shape like a valley. If it is a -3, it will look like a mountain. All right, so the first step is to actually do your calculation for your table. And in the same way, you will construct your table so that you have your X values in the first row, and your X value is going to go from -6 to +4. And your next row, you have a row for 3x squared. Then you will have a row for +10x. And then you'll have a row for -8. And then the final row will be the row for y. All right, so based on how many terms in the equation, that will help to determine the number of rows. All right, so your table should look something like this. So this is what you would get when you construct your table. And just to walk you through the calculations, I'll show you now how we arrive at our y value. So it is done in the same way as the previous table. So you have all your x values